Hi everyone, this is Ben from Math Online with Ben. Today I wanted to go over a few mixture word problems. I know these were tricky for me when I was going through school, and I just thought I'd make a video kind of talking through some of the thought process and underlying principles of these problems. So we can just jump in with this first problem here. This says Theresa blended 30 pounds of orange Picoee tea worth $6 per pound with 70 pounds of green tea worth $3.20 per pound. What is the cost per pound of the blend? So these are mixture problems because we're mixing different, in this case, teas worth different prices, and we're interested in the final cost per pound based on the prices of what we blended together. So the two things that we're caring about in this problem is the pounds of tea and the price per pound of tea. So my instinct here is I want to figure out first what are my total pounds of tea. So that's pretty straightforward. My total pounds is the 30 pounds of orange plus the 70 pounds of green. So together, this is going to be 100 pounds. I always like seeing numbers like 100 because they're easy to work with, especially when talking about percents or prices. So this is the total pounds, but what we're interested in is what is the cost per pound of the blend? Okay. Well, that means we're going to have to figure out how much the total cost of the tea is. So to find out the price, well, the price, if we're looking at, I guess we'll start with the 30 pounds, the orange tea is worth $6 per pound. So this is the kind of thing you could make a table. You could say, all right, 1 pound is worth 6, 2 pounds is worth 12, 3 pounds is worth 18. We'll see quickly that to find the 30 pounds, we just need to multiply 30 times 6. So this is going to come out to 180, and the units that we're talking about is dollars. So 30 pounds of this tea costs $180. We'll do that again for the 70-pound tea. So 70 pounds at, and if you're curious about the units, why this comes out in dollars, so this is 70 pounds, LBS, times the price of the tea, which is dollars per pound. So it's $3.20 per pound over LBS. So the reason why we only get out dollars here is because the 70 pounds actually cancels with the per pound. So we just get 70 times $3.20. I'm going to double check this on my calculator. This comes out to $224. Okay. So that means this is total pounds was 100. Our total cost is these two things added together. So $180 plus $224 comes out to $404. Now we can answer our final question, which what is the cost per pound of the blend? So cost per pound, this kind of tells you which numbers we're going to divide. So it's the cost, which is our dollars, per or over the pounds. So we take $404. We're curious about the price per 100 pounds. And what we get out is, this is why it's nice to work with hundreds, we get out $4.04. So this is the price per pound of our blended tea. One thing that you will want to keep in mind is always that this number should be between the things that you're mixing. So if you're mixing something worth $6 per pound and $3.20 per pound, you're not going to get something bigger than 6 or less than $3.20. So it's a way to check our answer, make sure that we're getting reasonable solutions. Okay. So that was number one. That was a nice warm up. It felt like we had a lot of information there. Really, we were just adding up our values and then comparing the totals. So let's take a look at something that's a little different here. So in this problem, Mike has coffee. Looks like we're switching over to coffee drinkers instead of tea drinkers here. So Mike has coffee worth $4 per pound that he wishes to mix with 20 pounds of coffee worth $7 per pound to get a mixture that can be sold for $5 per pound. How many pounds of the cheaper coffee should he use? So already this is a different setup because we're given the final price per pound. So we're not looking for that. We're actually looking for, if we kind of think about this visually, there's some amount of pounds of the $4 of the cheaper coffee that when we add it to the $7 coffee, which is 20 pounds, we will get some amount of coffee, 20 pounds plus something, and that this price will be $5 per pound. Okay. So I always like to draw this out because it just gives me a little bit of a frame of reference here. There's a couple ways I feel we can go about this. But I think we always want to start by defining the missing piece. So that's always going to be what we're looking for. What we're looking for is how many pounds of cheaper coffee. So if I pick a variable here, I'm always partial to x. X isn't just, we always want to be specific. So it's pounds of the cheaper coffee. All right, pounds of cheaper coffee. So that means we're always going to use it in the context of pounds. Now, from our drawing here, we can kind of piece together an equation, which is, okay, if X is the pounds of cheaper coffee, that's how much I need to add to 20 to get my $5 blend. So I know that X plus 20 is going to be my total blend. The total blend is also just 20 plus X. So we need to add some more information here, which is going to be the price. So right now, this equation is talking about pounds, but I'm going to add some values so that we instead are going to be talking about price. So to get the price of the $4, like how much value of the $4 blend we're using, I just have to multiply this by 4. So $4 times the number of pounds plus $7 times the number of pounds is equal to the total pounds times $5 per pound. So this works out well for me because I just have one equation and one variable. And I can just solve this out. So here I have 4x plus 140 equals, I'll distribute the 5. So this is 100 plus 5x. Seeing that I'd like my x to stay positive, so I'm going to move my 4x to this side, and I'm going to subtract my 100 from this side. So these guys cancel out. And I'm left with 40. Again, when we multiply this by dollars, it cancels the per pound cancels with the amount of pounds, and we're just left with dollars. So the units here is dollars. This is equal to 5x minus 4x is just x. And let's see, because, something happened here because we defined x as pounds of cheaper coffee. So this isn't going to be dollars. This is going to be 40 pounds of the $4 blend. Okay. So we can always double check. For some reason, my intuition is feeling like that's a little off. But $5 is less than 7 by $2, and 5 is up by 1. So maybe this is reasonable. We can always double check by saying $4 times 40 plus $7 times 20. This comes out to 160 plus 140 is 300. And our total pounds is, so this is dollars. And then our pounds would be the 20 pounds plus the 40 pounds, which is 60 pounds. So if we take our total cost over our total pounds, which is 300 over 60, we should get 5, which is exactly what we get. So that confirms for us that we have our correct answer, which is that we have to use 40 pounds of the $4 blend to make a mixture that we can sell for $5 per pound. All right. So just from the first two examples, you can see this goes a couple different directions. So let's see here what our last question is going to look like. So here we're talking about tickets. So tickets to the school play cost $4.50 for adults and $3 for students. One night, 325 tickets were sold and $1,140 were collected. How many of each type of ticket was sold? Okay. So we have a little bit of a hint here that we are looking for more than one solution. So here it says how many of each type. So each type, well, there are two types. There's the adult types and there are the student types. So we should always define our variables as what we're looking for. What we're looking for is the number of tickets that were sold. We know the price, so we're looking for number. So this will be number of student tickets. And this will be number of adult tickets. All right. So from here, we're going to, because there's two variables, we know we're looking for two equations. So those two equations are always going to reflect the units that we're talking about. So the two units that we're talking about is dollars and number of tickets. So the first equation I think is always easiest. It's just the number of tickets. So if X is the number of student tickets, Y is the number of adult tickets, and there was a total of 325 tickets sold, then our first equation, we're just looking at X plus Y is equal to 325. Not bad. The second part of this, so if this is talking about tickets, our next equation is going to have to talk about money. So this is where we have to build a relationship between the number of student tickets, number of adult tickets, and the total cost. So if one student ticket is $3, 2 would be 6, 3 would be 9. The relationship here is just multiplying 3 times the number of tickets. It's always nice to test yourself, like what does this 3x represent in the context of the problem? Here, we'll do the same thing for Y. So if one adult ticket is $4.50, 2 is going to be $9, and so on. So we know that that relationship is 4.5 times the number of tickets. So this 3x represents the total money spent on student tickets. This 450y is the total amount spent on adult tickets. So altogether, we know how much was spent. There were only adult and student tickets sold. They combined to $1,140. Okay. So this, unlike the question before where we just had one equation and one variable, here we have 2 equations and 2 variables. So we have to solve this system using either substitution or elimination. I don't have a strong preference for this. Part of me wants to practice elimination. So I'm going to multiply through this first equation by -3. And I'm going to rewrite it below my second equation. So my rewritten equation is going to be -3x minus 3y equals, and then I'll punch this into the calculator. 975, of course that's negative. All right. So let's not think about the units too much right now. Here, the reason why we multiply by this -3 is so that this 3x minus 3x cancels out. Here, 4.5y minus 3y, this is going to be 1.5y equals, again, relying on the calculator here, just to speed things up, this is going to be 165. Okay. So to solve this last part, we'll divide both sides by 1.5. So 165 divided by 1.5 is going to be 110. All right. So this is where it's important to remember and why I recommend defining your variables at the beginning. This y, this 110, represents the number of adult tickets sold. So 110 adult tickets were sold. Now we can just go back to that first equation. We had x plus y equals 325. So now we have x plus 110 equals 325. We subtract that 110, subtract the 110. We get x equals 215. Again, we go back to how we defined our variables. X is the number of student tickets. So, oops, looking for a Y there. So the number of student tickets that were sold is 215. The number of adult tickets that were sold was 110. So hopefully this gives you a little bit of an idea of the spread that you can see with mixture problems. So we can be looking for totals. We can be looking for always one of two variables, oftentimes price or pounds. You'll often see it as solutions, so like percent of bleach in a mixture of water, or so it'd be liters and liters of bleach, for example. So always make sure that you're looking for the right units, that you're comparing units correctly. And just take your time, draw out pictures if you need to, but hopefully this is just a nice general framework for you to practice